Okay, this is example 6, simplifying radicals by dividing in lesson 11.1, simplifying radicals. We just have this one and one more example, and then we're done with this lesson. So we're still dividing, but in this case, what you notice is you can simplify this fraction first. So if we look back at these other examples, you can't divide 144 by 9. You can't simplify it. You can't divide top and bottom by 2 or by 3. Same thing with 75 over 16. You can't simplify that. You can't simplify 25 over q squared. So if you can, though, you always want to simplify your fraction first before you start taking the square root of the top and the bottom. So 120 divided by 10 would just be 12, so we have the square root of 12. Then we want to try and simplify that radical. So I have the square root of 12 would be 4 times 3. And I used 4 since it's a perfect square. I could have broken it down to 2 times 2, but I was going to pull it out anyway. And then the square root of 4 is 2, so it comes out, and we're left with the square root of 3 inside. And if you want to check to see if your answers are right, you can do this with any of them that don't have a variable. Put this in your calculator, the square root of 120 divided by 10. Then put 2 square roots of 3 in your calculator and just see if they're the same answer. If you get the same answer, you know you did it correctly. If you don't, then you made a mistake somewhere. Let's try that same thing with this next one. 75, 7 plus 5 is 12. It's divisible by 3. 4 plus 8 is also 12, so it's also divisible by 3. So first you want to simplify it. 75 divided by 3 is 25. So it's still the square root of 25x to the 5th over, and then 48 divided by 3 is 16. So 16x. So all we did was simplify our fraction. I divided top and bottom by 3. But then I noticed I also have an x on the top and x on the bottom. So if you remember back from, I think it was chapter 8, we can also simplify our variables. So I have 25 divided by 16. Then when you divide, remember you subtract your exponent. So x to the 5th minus the 1st, that gives me x to the 4th on top. I no longer have a variable on the bottom. Remember, you always write it on the top. X to the 5th minus 1 is x to the 4th. Now it makes it really easy to take the square root of this fraction. I have the square root of 25, x to the 4th, divided by the square root of 16. The square root of 25 is 5. The square root of x to the 4th, remember, just halve your exponent, so it's x squared, over the square root of 16, which is 4. And you really don't need to simplify this. It's already really in simplest form. I know it's an improper fraction, but that's okay. So let's try some more like that. Because on your test, actually, I guess we didn't write any like those. Well, let's look at Quick Check 6, because we definitely want to do some more of those. Quick Check 6. So here are a couple. How about the square root of 90 divided by 5? So again, as we look at this problem, we notice, I can definitely simplify that. What is 90 divided by 5? 18. So now I'm taking the square root of 18. Again, I just divided 90 by 5, so I have the square root of 18, and then I want to break down 18. 18 would be 2 times 9, and 9 is a perfect square, so I'm going to leave it so I can take the square root of it. The square root of 9 is 3, and then the square root of 2 has to stay inside, so 3 square roots of 2. Let's look at another one. How about, actually, instead of B, let's look at C, because we just did one like B. So C is the square root of 27x cubed divided by 3x. This is another one where you can divide 27 divided by 3. So that's the square root of 9. 27 divided by 3 is 9. And x cubed divided by x, you just, again, subtract those exponents. 3 minus 1 is 2, so it's x squared. The square root of 9x squared, the square root of 9 is 3, and the square root of x squared is just x, 3x. All right, now let's go on to look at our very last example, example 7. This is rationalizing a denominator. When you rationalize a denominator, basically take your calculator, find the square root of 7. It gives you a crazy number. The square root of 7 is 2.64575131. It's a totally irrational number. So what we mean by rationalizing the radical is to get this, or rationalize the denominator rather, what we mean by that is to get this radical out of the denominator. We cannot ever leave a radical in the denominator. So just like you can't divide by 0 because the world will explode, you can't divide by the square root of 7 for the same reason. So we need to get rid of the square root of 7. And to do that, we do something called rationalizing the denominator, which is multiplying the numerator and the denominator by the square root of 7 divided by the square root of 7. Now, what is the square root of 7 divided by the square root of 7? Well, it's the same thing as what's 7 divided by 7. 7 divided by 7 is 1, and the square root of 7 divided by the square root of 7 is also 1. So we haven't changed our problem at all. We're still following our rules of algebra. We're not allowed to just change things. We're simply multiplying by 1, but it's going to do some really great things here. So we just multiply across 3 times the square root of 7. Remember to think of this radical as like an x. So if we did 3 times x, it would just be 3x. So if we do 3 times the square root of 7, it's just 3 square roots of 7. Divided by the square root of 7 times the square root of 7 is the square root of 49. Oh, and look, it's a perfect square. We can take the square root of it. So we have 3 square roots of 7 divided by 7. And now we no longer have a radical in our denominator. We have rationalized it. This is a rational number. There's your answer. You can't do anything else to it. Can't simplify it, so you're done. Let's look at B. Same thing. We have a radical in our denominator. We need to get rid of it. So we need to multiply top and bottom by the radical in our denominator. So times 12, the square root of 12x cubed divided by the square root of 12x cubed. Then we just multiply across. So remember that when you multiply radicals, just multiply your numbers together. 11 times 12 is 132, so we have the square root of 132x cubed divided by 12 times 12 is 144, so the square root of 144. X cubed times x cubed is x to the 6. And then we just want to simplify. So remember that 132 was 11 times 12, and 11 is a prime number. So if I was to break down 132, I'd say 11 times 12 is 4 times 3. 4 is a perfect square, so I'm going to leave it as 4 times 3. And then x cubed would be x squared times x. Then on the bottom, the square root of 144 is 12. And then x to the 6, again, just have that even exponent, so it's x cubed. Now let's take care of the top. We can't take the square root of 11, but we can take the square root of 4, that's 2. And the square root of x squared is just x. And then what's left inside? 11 times 3 is 33 times x, so 33x, divided by 12x cubed. Okay, now on this one, we can still simplify. So we want to go ahead and keep simplifying as much as we can. So I have 2 divided by 12. That simplifies to be 1/6. So basically, we just get rid of that number on the bottom. Actually, I'll go down here and start working. It's 1/6, so it's 1x square root of 33x over 6x cubed. And then we both have an x here. So if we were to use our rules from Chapter 8, we know that we subtract our exponent. So this would be, on top, we'd have, and we can get rid of 1 because 1 times x is just x. So I'd have x to the first minus 3 times the square root of 33x over 6, and sorry, there's no more x now because we actually moved it to the top, so over 6. And that equals, well, x to the 1 minus 3 is x to the negative 2, square root of 33x, over 6. But we know we can never have a negative exponent, so you move it to the bottom. And we have the square root of 33x divided by 6x squared. Woo, that was a long one. Finally got to the end of that one. So let me review what happened here. And really there are some shortcuts you could take. For instance, right here I would just say, okay, 2 divided by 12, that's 1/6, and so I would just have my 6 on the bottom. And then I'd say x divided by x cubed. You know that your variable is going to end up wherever your larger exponent is. So since the cubed is the larger one, I knew right then my x was going to be on the bottom. All I had to do was subtract, and then I know it's going to be on the bottom. So 3 minus 1 is 2, and then just put your variable wherever your larger exponent was. And that'll help you skip these 3 steps right here. You really don't need those you can remember that your variable will always go wherever your larger exponent is. Like it did in this one here, our larger exponent was 3, and so our exponent did end up on top. X squared was on the top of the fraction. Here, x cubed was on the bottom of the fraction, and our variable did end up on the bottom of the fraction. Also, something else you may have noticed, when we multiplied the square root of 7 times the square root of 7 and got the square root of 49, we ended up with 7. So the square root of 7 times the square root of 7 is simply 7. And actually, that's a rule. It will always happen. Anytime you multiply a radical times itself, that number will pop out of the radical. For instance, if you do the square root of 3 times the square root of 3, you get the square root of 9, which is simply 3. So notice, 3 just pops out. Same thing with the square root of 4 times the square root of 4. That's the square root of 16, which is just 4. Again, it just pops out of the radical. So that's another thing. If you can remember that rule, you can skip this step here. You can skip having to write the square root of 49 and just say the square root of 7 is the square root of 7. Well, I know it's just going to be 7. It pops out of the radical. Those are some time-saving tips for you. So let's try a couple more before time runs out. So again, rationalizing the radical, we have to get this radical out of the denominator. So times the square root of 3 over the square root of 3. 3 times the square root of 3 is 3 square roots of 3, divided by the square root of 3 times the square root of 3. That's the square root of 9, which is simply 3. Then we can, 3 divided by 3 cancels, so we simply have the square root of 3 as our answer. It's fine to have a radical as long as it's in your numerator, not your denominator. So let's look at B. Our radical is the square root of 18t, so, sorry, I keep writing that equal sign. So I'm going to rationalize by multiplying the numerator and the denominator by the square root of 18t. Remember that this is just 1, so I'm not changing my problem. Then I have 5 times 18, which is 90. So I have the square root of 90t divided by 18t times 18t. Remember, again, it just pops this out. So it would be 324t squared. So then if you took the square root of 324t squared, you would just get 18t. So again, if you'll just remember that rule, any radical times itself pops that term out of its radical. You'll save yourself a lot of time. So let's deal with the top now. 90 was 5 times 18, so 5 times 18 is 2 times 9. 9 is a perfect square, so I'm going to leave it, times t, over 18t, and then we want to pull out everything we can. So we can take the square root of 9, which is 3, and we have to leave in 5 times 2 is 10 times t, 10t, over 18t. Now we can simplify again. You can't do anything with this radical. You cannot divide a radical and a non-radical, but we can simplify 3/18. 3/18 simplifies to be 1/6. So I have the square root of 10t over 6t. And we don't really need that 1 there for the same reason why we wouldn't leave a 1 in front of an x. It's understood. So the square root of 10t divided by 6t is our answer. All right, let's try and do one more. So this one, they didn't split up for us yet. So I'll go ahead and split it up first. 7m, the square root of 7m divided by the square root of 10. Now we need to rationalize our denominator by multiplying times the square root of 10 over the square root of 10. Then just multiply across. 7 times 10 is 70, so the square root of 70m divided by the square root of 10 times the square root of 10 is the square root of 100, which is simply 10. Again, it pops out. 70, let's try and simplify that. The square root of 70 is 7 times 10. 10 is 2 times 5. Notice these are all prime numbers. We have no pairs, so there was nothing we could pull out. So that right there was our answer. That's the end of 11-1, and I'll see you in class for questions.